Hi, welcome to Next Level Technical YouTube channel. So, for this particular video session, I'll be talking about Mpls based layer 3 VPN, or you can also as well call it VPN V4. So, in this particular session, I'll be using Cisco routers for this configuration and demonstration. However, on my channel, what I normally do is whenever I carry out any configuration on Cisco, I'll try my best to replicate the same using MikroTik router. When I do one on MikroTik, I'll replicate it on using Cisco routers. So for this particular video session, it's actually a little bit advanced, and you find this topic in CCMP or MTCROE, as in the case of MikroTik for MTCROE. And there are prerequisites you need before venturing into such configuration. And this little literature is actually an overview of what is needed before venturing into it. You actually need a knowledge. You need at least some level of knowledge in interior gateway routing protocol, interior gateway protocols, such as the enhanced interior gateway protocol, open shortest path first (OSPF), or uh, intermediate intermediate system to intermediate system, which is also a routing protocol. OSPF is link state, ISI is link state, AIGRP is distance vector protocol. So you also need a BGP, a border gateway protocol, that we will use as a multi-protocol BGP in this configuration. It is actually a protocol in terms of exterior gateway protocol. That's a protocol that powers the internet. First of all, the interior gateway protocol, which is used in a domain, it is actually an extension of BGP that we use for multi-protocol BGP within a domain. So it carries several address families such as IPv6, IPv4, and VPN v4. So, and you actually need a multi protocol label switching as well to accomplish this task, and then a VRF, virtual routing forwarding, to accomplish this task. So most of the video sessions you have been seeing, and I believe you have seen online, basically make use of 1 to 4, as in a network without tunnel, just on Ethernet. So in my own case, I'm assuming you are connecting different branches through an underlay network, maybe a network, an existing infrastructure from ISP, but using an overlay protocol like DM VPN to establish a tunnel across such network. So I'll just explain briefly so that we'll move into configuration uh, in, in details. So some of the benefits of MPLS layer 3 VPN is actually they provide some level of privacy or security to the customer or those that are using the services. So it allows that's to the customer actually. So it allows for scalability in the service provider environment. It's actually service provider. Uh, it's actually more useful for service provider basically, but you can use it depends on whatever design you have. It allows for scalability in the cellular environment. It provides privilege for service providers to provide one or more customers who are using the same block of IP. In this case, if you are using a private IP defined in ROFC 1918. So, and for example, what I'm trying to explain in this is that this virtual routing forwarding is actually a means of breaking up a single router. What I mean is that instead of having one large routing table, you can have several instances of virtual routing forwarding in just one physical hardware router. So a customer that is using, let me say, 172.16 range of IP, 172.16 range of IP, with another customer using the same range of IP, if you are to service them, give them service, you might actually have issues. So because they might be conflict in the network, but with virtual routing and forwarding, you can actually achieve more with that. Or you as a service provider, you are having the same network range with the customer you want to give service to. So virtual routing forwarding is actually one of the way forward. So and that is that for virtual routing forwarding. So why do we actually need an IGP in this case? One of the reasons because we need the loop back, we need loop back reachability in in IBGP, which is interior border gateway protocol. Like I earlier explained, it is actually an advanced topic, but if you are new to the system, you can actually just stay and you can actually learn and even pick up from here and be curious and decide to know more about all these various protocols used here. Why IGP, the second reason is to propagate LDP, label distribution protocol, within the network. Understand? So um then so for this MPLS, actually the brief intro to MPLS. MPLS is actually known as it's sometimes called layer 2.5 protocol on USI model because it can carry anything over the MPLS part, irrespective of the underlaid network, Ethernet, PPPP, which is point-to-point protocol, ATM. So LDP label distribution protocol is open standard and uses port number 646, and it is the protocol that is mostly used to exchange MPLS labels. So there's also another protocol called TDP, Tag Distribution Protocol, that is Cisco proprietary. So in this, for example, we're making use of AIGRP. So and for this enhanced interior gateway routing protocol, I, I it is actually Cisco proprietary as well, but it has not been made open standard. It has not been made open standard. So then for the VROF, I'm trying to just give little intro of all these protocols we are seeing here. So for the VRF, this is actually meant for virtual router forwarding. So this allows, like earlier explained, this allows router to run more than one routing table simultaneously. So VROF without MPLS is called VROF Lite. I'll leave a theory, a link uh, on the configuration, the steps, and this overview, just a brief intro to all these protocols. And then inside that same VROF, you have what we call route distinguisher. It's a 64-bit number that is appended to a 32-bit address. So the format of representing is its ASN, where ASN is being the service number and the NN being the number identifier. You'll see that when I'm doing carrying out the configuration, and then we have the ROT as well, which is route target, which actually defines VPN membership as they allow router to control import and export of routes amongst VRF. So this last package that I'm actually adding to this, that actually, because you said, as I said, this is a complete package. Many videos you see is from 1 to 4, but I'm adding DNVPN. So DNVPN, which is called a dynamic multi-protocol VPN, is actually one of those protocols from Cisco, one of those innovative protocols from Cisco as well. So I will explain just briefly. You can also make more research on it. So so let me just say when in a modern real time. When something in a modern real time application such as IP telephony, or maybe you are doing a broadcast video or telepresence or IP video surveillance and send any other sensitive uh, service delivery, maybe like voice call and all that. You understand? So for a real time traffic, network latency should be less than 150 milliseconds. Network latency less than 150 milliseconds. So so for hubs and spoke network, let me give, I think I have a diagram below here. I have a diagram. Okay, this is a diagram for hub and spoke network. A network where you have a branch office that before you get to another, when you have a hub and branch and several other spokes, which is connected to the hub, whereby where a spoke want to communicate or a branch B want to communicate to with another branch somewhere, they have to transverse, or the traffic has to go through the hub first before getting to the other end, which is the spoke. You understand? So if you see in this diagram, I actually said, and in a scenario where you have 80 milliseconds before you get to a hub, and maybe this particular spoke want to get to branch B, meaning that it will spend 80 milliseconds to get to hub and then another 80 milliseconds to get to the branch. And you see this is actually above the recommended 150 milliseconds. Actually, Cisco said 200 milliseconds. So I think ITA or ITU or so said 150 millisecond latency for uh, real time traffic. Real time traffic, as in what is like as it is happening, such as video or voice calls or telepresence. You understand? So you need at least 150 milliseconds to maintain real time traffic. So in a situation where you have a spoke want to communicate to this spoke, you have to transverse to the hub, you now have about 160 milliseconds, which is not actually within a recommended of 150 milliseconds. Cisco, within its wisdom, came up with a tunnel called DMVPN. So what does that DMVPN do? Instead of it transversing between this, it will create a tunnel directly. Your initial configuration as administrator definitely is going to be to the hub and not to the hub. But dynamically, DMVPN will establish a tunnel after a while of first communicating, first establish communication between branch A and branch B. After a while, a tunnel will be established directly between them using the underlay network. It actually uses a next up resolution protocol to achieve that. So this is the second diagram that I did. So in this scenario, I'm not saying 80 milliseconds is going to be what the service provider gives to you. It might be less. But what if you use DMVPN with it? You will have a much lesser milliseconds and a very smooth video call, voice call, and all that. So in this case, 80 milliseconds to the branch, 80 milliseconds to the other branch in the first case. And after the first and second phase, with the DMVPN phase 3, you understand, you see the configuration, the dynamic VPN tunnel will be created. And you see, instead of 180 milliseconds, it will be reduced to 100 milliseconds. So that's one cool protocol about, cool thing about TNVPN. Unlike the GRE that you have to run the traditional link directly to the hub, and it must transfer to the hub before getting to the branch. So without any further delay, I will be going into the configuration in detail. However, this is going to be a little bit of a lengthy session. It's going to be a little bit of a lengthy session, but I'll try as much as possible to make it brief. Try as much as possible to make it brief. So let me go to the topology for GNS3. So this is a diagram I'll be using for this particular session. Let me zoom out a little bit. So for this diagram, you will see the color here in blue, another in red, another in yellow. This particular yellow diagram is this particular yellow diagram is actually the service provider um, diagram, service provider session, ISP domain. While this yellow is a different branch with the same branch. Let me and I name it B hub. This B hub can be let me say UAC, it can be CAT, it can be whatever company, meaning that this yellow are the same company, the same company, this blue are the same company, the same company, the same company, connected by an ISP in this domain. So and the ISP itself is connected to internet, which is the world wide web there out there. So and what I want to do with this is that and this particular domain, ISP domain has an AS number of 65,000, and I'll be using a loopback IP 10.10.10.s, meaning that this P, which is a called provider, and PE is called provider edge, and I name it provider edge 2, provider edge 1, provider edge 2. And if you see there, I wrote arrow, which means route reflector router. I can actually use this same P as a route reflector router, but I decided to introduce this to be the route reflector router as well. You'll see when I'm doing that configuration. So and so in this particular setup, like I earlier explained with VRF, I'm going to be using the same subnet of IP for this branch and this branch, and they will communicate as if they are separated. However, they are connected to the same device and unaware that they are actually using um, let me say MPLS or whatsoever it is that is used within the ISP domain. And also for this MPLS, there are 3 VPN. The service provider partake in the routing process with the customer, either by using static IP, which is most common in many ISP, or by using any of the dynamic protocols. So for these hubs, I'll be using BGP for the ISP here to participate with them. While for this, I will use EIGROP, I will use OSPF. Here I will use OSPF, I will use EIGROP. It's actually going to be a lengthy video. And for this domain within the what do we call it, within the ISP domain, I'm going to be using EIGRP. Actually, OSPF scale very well with MPLS, and EIGRP scale very well with DMVPN. Any of the protocol can work for any of the services that I just mentioned, but in my own case, I just wish to use EIGRP in this environment. So let me see if there is anything I need to show you again on this diagram. So for this diagram, like I earlier said, the red diagram are going to be using 10.30.30 range for loopback, while the blue diagram are going to be using 10.20.20.20 for the loopback. And then red 10.30.30.3, 10.20.3 for the all 10.30.30.1, while for this guy here 10.20.1. So without any further delay, okay, let me explain briefly as well. So for all these ISP routers, these 4 routers connected to this cloud, they are connected using BGP to this cloud. You understand? So and I will create a tunnel. That tunnel is going to be a DMVPN to which they will share routes in between. Routes can be shared and reachability can be accomplished within these 4 routers. So without any delay, let me go into the routing in details. So I will log in into this provider router. Let me log into PE router as well. So in another video session, I'll be carrying out the same configuration, the same setup using MicroTik. But let's do Cisco here. So for the P router, let's quickly go through and see what we have. Show IP interface brief. So I only have IP assigned to ETA 1, which is the one connecting to the internet. And then let me do the same here. Both on is on show IP interface brief. I think I need to bolt this stuff here. So and sorry, let me quickly close this. So um, let me do the same here. Show IP interface brief. Just IP address assigned to those interface, and they are connected using VLAN. Show IP interface brief. So those are just what is connected here. So I will now go into this router and establish a BGP uh, connection config T. Let me so router. Remember in this particular diagram, I said we are going to be this ISP environment is using autonomous system 65 65,000 autonomous system 65,000. So so there's something I want to quickly explain to you about this autonomous system number. Actually, there are numbers assigned by IANA. You understand? And IANA is the larger body. So, but each continent have their local internet registry body, the RIA, regional registry body that's assigned IANA to them. So, however, when you are carrying out your lab, ensure that you use the private range. The private range are about 1023 in numbers. So they are between 64,512 and 65,534. If you buy a new router, you notice that it's using the default a new router as in the version 6 routers. If you log in, you notice the the ASN is in private range. So uh, to use the public range, you have to consult your regional internet registry for that. So when your lab, ensure you use the private range. As I did here, all these are private range. ASN for the blue company is 6501, ASN for the red company is 6502, for the ISP is 6500, while the internet that is giving the upstream service, which is the internet as well as BGP, is like a ear-to-ear protocol. That is why they call it path vector protocol, because that is actually used to that's how it powers the internet from ASN to ASN. So yes, this internet is using 649999 triple nine 64,999. So let me so that in case you see it here, you'll not be worried. So I'll be using 65,000 within the ISP router BGP 65,000 for the ISP, and then I will there's actually this I say no BGP default IPv4. Okay, so I'll say no BGP default IPv4 unicast. But let me stop here. Why I'm doing this is that I want to be making use of address family. You don't actually need it, but it is actually a nice thing to do so that you see how in each address family everything organized. No BGP IPv4 unicast. They are now define Neighbor. Neighbor is going to be my IP here is 172. So my neighbor, because it's slash 30 IP. Let me show you so that you see. Do show run interface Ethernet 1.0 slash dot 10. So that is the 252, which is the service provider is dot one. So I'll say neighbor this IP 172 172.16.10.1. Then define the remote AS. The remote AS is 64999. Um I have to define this. It is actually a nice thing to do, but if you don't do it, the router will choose the IP with the highest prefix. But I love actually defining a loopback IP when I'm configuring any dynamic protocol, be it BGP, OSPF, or whatsoever. I always like having a dynamic, having a loopback IP. So IP address 10.10. Let me see the address I said I'm going to be using for ISP. I'm using 10.10 range. So it's 10.10.1. This is the first IP provider IP, which is the core IP. 255.255.255.255, which is actually a slash 32 IP address, more like an identity for this router. So I'll go back to the PGP process. I've actually defined the remote AS. Then there's something I need to define. The BGP is not up yet because I have to go to address family to activate it. So what else I need to do is BGP router ID 10.10.1. So I'll go to address family IPv4 unicast. Then I'll go and activate this particular uh, um, IP address, which is this 17 neighbor 172.16.10.1 activate. So in a few moments, the BGP session should be established. Let me ping. Okay, it is up now. So now it's up. If I do show IP route BGP, I should be having a session. The default gateway coming from the BGP. So that's that for that. I've established connectivity here. So I'll do the same thing for this guy here, config T. No, before that, interface loopback one, IP address 10. It's actually a logical interface. It will come out automatically when you go into that loopback config mode. Then 255.255.255.255. That's that. Then router BGP 65,000. No BGP default IPv4. Okay, IPv4. BGP router ID 10.10.10.10.2. Then neighbor 172.16.10.5. Remember, this is slash 20 slash 30 IP. The ISP, which is the gateway, is dot 5, and that is the neighbor. So BGP, this guy, the remote ID, the remote ASN number of the service provider 64999. I'll go to address family IPv4 unicast, and I'll go and activate uh, that service provider I72.16.10.6 activate. Uh, okay, dot 5, sorry. My bad. It's 5 and activate. If in a few moments, it should be up. So and by default, if you don't do uh, uh, if you don't do neighbor, if you don't do neighbor 172.16.10.5, send send community uh, by default. This is what happens in the background. Send community standard because but if you are doing VPN before, you are not to use standard, you are supposed to use extended. When we get to that session, you'll see it. So let me exit this and I say do show. Let me see, do show. Okay, let me confirm that if there's a session, do show BGP IPv4, IPv4 um, unicasts. So I actually have what do we call it? The installed route in the BGP table this is the BGP installed in the BGP route and this is the BGP table. So that means there's address family into unicast who is sending me all these messages. Neighbors. Okay. Neighbors somehow unicast. If I've actually forgotten this command. Okay, so that's the neighbor. That's the neighborship I just formed. Do show BGP before unicast summary. So that is the neighborship I just established. So let me quickly do this as well. Config T interface loopback one IP address for this loopback is 10.10.10 dot 3 255.255.255.255. So that's that for that. And what else now? I have to go to the BGP process router BGP 65,000 and then no BGP default IPv4 unicasts and then BGP router ID is 10.10.10.3, the one I just created. And then the neighbor, let me define the neighbor 172.16.10. Look at this here is dot 9 and the remote AS to that ISP 64. I'll go to address family IPv IPv4 unicast to activate it. Neighbor 172.16.10.9 and I say activate. This in a few minutes should be up. So let me configure this. Config T interface loopback one IP address 10.10.10.4 255.255.255.255 and then the process router BGP 65,000. Let me check if this has come up. Yes, that agency has been established. Router BGP is divided. No BGP default IPv4 IPv4 unicast and BGP router BGP router ID 10.10.10.4 and then the test I'm not gonna do and now initiate the neighborship 172.16. The IP address is 14, ISP is 13, which is the gateway. Dot 10, 172.16.10.13. The remote AS is 64,999. So I'll go to address family to activate it IPv4 unicast and I'll say um, neighbor 172.16, the 10 the dot 13 and activate it. So it should be established now. So with this, I've actually set up this. You can see in a few minutes it should be up. This one is up, and then that's that. So let me now define the DMVPN before I define the protocols. So to define the DMVPN, let me go to my diagram and see the IP I'm using for my DMVPN. Let me see. Okay, IP address. Okay, this is for the service provider. This is for the customers. So I'm going to be using dot 18 for the DPS 172.18 range with DMVPN. So interface tunnel 10. I'll say IP address 172 dot. I'm using 18 range dot 18 dot 10 dot 1 255 dot 255 dot 255. I'm using slash 28, which is 240 for the tunnel. Let me really do show IP interface brief, excluding excluding down. So I'll do a tunnel source. Tunnel source is going to come from here. Tunnel source will come from here. Even if you are configuring your normal GRA tunnel, this is has to be specified. And in GRA tunnel, you have to do tunnel destination as well. And then it pointing to the underlay network of the other end you want to access. So for GRA, this is the command to for DMVPN. The command to activate DMVPN is going to be tunnel mode. Let me give you option. You have several options to use. Tunnel mode by default, even in GRA, you can say tunnel mode GRA, but by default, if you do GRA configuration, this is what will be activated for you. Tunnel mode GRA IP. This is what will be activated in the router. So in this case, I am going to be using GRE multi-point. This is the command for DMVPN to start with it. So DMVP, that's for the DMVPN. Then I'll now initiate the NHROP process. So I'll say IP NHROP. I'll specify network ID. This network ID has to be unique across the network as well. IP NHROP network ID, because this particular um, area here, that's going to be the hub. And what I'm doing here is a direct phase 3 configuration. No, I'm not passing through those processes of phase 1, phase 2. This is phase 3 direct connect configuration. So IP NHROP uh, map dynamic, let me see, multicast dynamic. So this this is the only place I'm going to be using for my for the um, for the hub, because this particular P, which is the provider, is going to be the hub for the ISP. And then what else do I need here? If assuming I'm using several tunnel within, I have other DMVPN process running, I can now specify tunnel key. It's optional, but I'm not doing that. So I have to, let me see, um, do show run interface tunnel 10. So IP initial P, this guy, tunnel source, and so for the hub, I'll say IP NHROP redirect. The essence is that in my former diagram that I showed, such that the former diagram I showed, I've actually closed that. Um, let me see if you can bring it up. So in my folder, this IP initial OP redirect, what it actually does is that when a hub sends an information to the when a spoke send an information to a spoke, then the hub will do a redirect such that a tunnel can be created between the two of them, and it has to be used hand in hand with the spoke using at the spoke end to be an IP initial OP shortcut. So I will enable this. I think that's all for this. Let me rerun if I have any other option. This is just um for the hub. This is what is needed. I'll now go to scope. I'll say interface on 10. There are two approaches to configure this configuration here, but so as IP address on this interface, what I assign is this guy. So what I'll be using here is going to be 2, and then let me show IP interface brief excluding down. So this is going to be my tunnel source. I like using the IP address. If you say tunnel source, you can actually use the physical interface, but in my case, I'm using the IP address because if you do options, you see several source, fast Ethernet, Ethernet, and gigabit Ethernet. Let me see this gigabit Ethernet here. So if there is, I would have seen it here, but fast Ethernet or Ethernet. So you can use any of them as a source. Probably this router is running fast Ethernet. That's the highest interface. So that's why I'm seeing fast Ethernet. If there's a gigabit Ethernet supported, I would have seen it here. So I'll say then source. Then the source is going to be this particular IP address. The tunnel should, I'll now say tunnel mode GRE multi-point. So the internet should be hub. I will now start defining IP NH, IP NHROP. IP NHROP is going to be next NHS means next observer. This is for the command for the spokes. Next observer. And the next observer is going to be the IP address on the tunnel itself. This guy. So that is what I'm assigning there. And the end, I'll specify NBMA, non-broadcast multi-access. Non-broadcast multi-access is the underlay network for this hub. And the underlay network is this guy. That is that connects to the ISP. That is what it's going to be using to establish this connectivity. And it uses multicasts. So, and then, oh, let me see the option here. I'll specify, I'll say multicast. I think that's the last. This is actually the latest command used for DMVPN, and it is available, I think, from iOS code 12 and above or so. So I'll click enter. Then I don't know if I IP initial OP uh, network ID 10. Let me say do show run interface tunnel 10. Let me see. So I'll do IP NHROP shortcuts. Those are for the spoke. Just as I earlier explained in the hub when I was doing the configuration for redirect. At the spoke is shortcut. So let me confirm if there's a DMVPN. If DMVPN is established, to show DM. So the DMVPN tunnel is up. The state is up here. So this approach that I use is the latest command to be used. For now, I'll be using another kind of command here. But before this DMVP and whatsoever, it's just like I'm connected, like I earlier explained this diagram, connected to internet. Public IP should be reachable at all corners of the world, except there's a firewall rule blocking that public IP from not reachable. So I'll do the same here. Okay, I'm not configuring BGP here because I'm going to do show IP route. There's okay BGP. I'll configure BGP here. Do show run session BGP. Okay, okay, I've done that here too. So let me configure the tunnel interface tunnel 10 IP address, which is the overlay network IP address, which is this guy here. I'm going to be using, I used one, two, three, four. I'm going to be using four here. So I'll now say, let me do show IP interface brief, excluding the down. So my tunnel source is going to be this guy. That's my tunnel source. And the tunnel mode is going to be GROE multi-point. I've not even configured the MVP here. It's going to be multi-point. So like I earlier said, I'll be doing a different config. I'm not going to be using this modern config, straightforward config. I'll use what I've been used earlier before now. IP NHROP desktop server 172 dot is it 18 I used earlier on? Let me see. Dot 18.1 dot 10. This is what most people actually are used to. I'll just enter IP NHROP map. So the next top server is going to be specified, which is this guy. And then I will specify the underlay network, which is the service provider network for the hub. Uh, that is all, which is NBNA. Then I will now specify IP NHROP map multicast. So I'm going to specify this time around only the NBNA of the hub. This is the command people are used to. IP NHROP network ID 10. So let me confirm do show DM. So my DMVPN is in upstate. There are other optional config you can do, like IP MTU. Because it's a tunnel, by default, the interface MTU is 1500. So for some certain packet to go through without, because some routers will actually drop packet that are too big, maybe the end router, because you can only control your domain. You don't know what your ISP or service provider configure on the database. So you can actually drop your MTU down to, let me say, 1400 as an example, but I'm not doing that. And also drop your IP TCP MSS, TCP MSS. Let me see, IP OTC, TCP, IP TCP, adjust MSS to maybe 1360 or so. But meanwhile, I'm stopping here. Then that is why it is good. At least MTU size are increased on your interfaces. So for me not to waste time, because I'm going to use the same config here, I'll use the test editor. So let me show GM. Nothing is running here. So let me do show run interface tunnel 10. So I'll copy this config and edit just a few things there. Alright, so this was the test editor I wanted to use. So let me just quickly just spell it out as well. Interface, let me first of all confirm. No interface tunnel 10. Let me do show PGP IPv4. Unicast summary. So that is the neighbor. We show IP route. PGP. Let me see if I can ping the underlying network of the hub 16.10.2, and I can ping so interface tunnel 10. The IP address on this interface to show the interface brief. Okay, so uh, IP address the overlay network 172.18.10.3, 255.255.255.240, and then show IP interface brief excluding down the tunnel source is this tunnel keyboard GROU multi-point IP NHROP network ID is 10. IP NHROP shortcut IP NHROP desktop server 172.18.10.1 IP NHROP map desktop server IP 10.1 uh, NVMe of the desktop 172.16.10.2, which is the underlying network of underlying network, which is this here. This is the second method of configuring NHROP here. And I said IP NHROP um, map multicast underlying network of the desktop of the hub. Let me do show which address is registered already. Okay, I think I need to use another IP address. IP address 172.18.10.5 255.255.255.240 ratio DM. Okay, so basically this DMVPN is on because actually I think that thing is registered already on the NHROP table already. So, but let me do show run interface tunnel 10. So the configuration I did for this desktop is what people are used to. They will define the desktop server, they will define the NHROP map, which is the desktop IP address, and the underlying network. They will not define the NHRP multicast, which is also the NVMe, the underlying network of desktop address. While with a single command, you can establish that same do show run interface tunnel 10. Reducing IP NHRP desktop server, NVMe this and multicast, you are done. So I will have to just to make everything nicer, I have to define a static route IP pointing to the server to avoid recursive routing. 172.16.10.0 255.255.255.252. Oh, sorry, and then the gateway, which is the next up 172.16.10.1. We show this is not dot one. My bad. This is actually dot. Let me see the IP address. Okay, this is 5. This is dot 5. this IP is dot .5, it's /32 IP slash 30 IP, and then the gateway is dot .5. So that's the IP route. Let me remove the first one. So we show IP route. So that's the static IP that I just defined, and then the BGP. I'll do the same thing here. IP route 172.16.10.0.255.255.255.252, and then the gateway 172.16. This is the next hop of 10 dot 9. Do show IP routes. The static IP is present there. So I'll quickly go here. IP route 172.16.10.0.255.255.255.252. The gateway 172.16.10 dot dot 10 dot 13. Do show IP route. Let me confirm. Okay, it's actually present there. So I am basically done with DNVPN because it's actually now running. So by default, I'll go to global mode. By default, MPLS IP is enabled by default. So just to if you want to enable it, if it's not enabled, by some reason it is disabled, you see MPLS IP. I'll go to interface tunnel, the tunnel with which I want the MPLS to take part in, to use to propagate label. I'll define MPLS IP there. If it were OSPF, I'm using this domain, I would have said LD, LD, uh, MPLS, LDLP, um, let me see, MPLS, LD, uh, I've actually forgotten the commands, MPLS, um, IP, forgotten if it were MPLS I'm running. MPLS, I think auto config or so. I've forgotten that command that I would have issued here. So I don't need to be defining those MPLS or those interface. I need to just propagate itself anywhere MPLS, anywhere OSPF, any interface OSPF is using. If I find out, if I get it later, I will issue it here. So and then I have to come to um, this place MPLS IP because I'm using GROP interface to 10 MPLS IP, the same thing MPLS IP interface tunnel 10. These are just what I need to do to activate the process. MPLS IP. I'm going to okay. That particular config that I was talking has to be activated within the OSPF domain. I'll run it. I'll remove OSPF process. Let me just see. MPLS IP interface tunnel 10. So MPLS IP EIGRP. So let me quickly just confirm that. But I'll remove the OSPF process router OSPF one. Uh, MPLS auto config. Okay, MPLS LDP auto config. With this command, anywhere I wanna specify, I can just stop this way. Any interface that participates on OSPF, you understand? This MPLS IP will automatically be activated and go through those interface. Then if I'm to specify with area that I want it to go through, I can just specify with the area. So this is the command I was trying to remember. So I just remembered now. So I have to remove that OSPF process because I'm using AGIGROP here. So I'm done with this. Now let me just confirm the DMVPN, the NHROP table. Do show DMVPN. So this is the table that is actually now showing. This is the IP. This IP was registered before, so I have to clear it out. So 5 is what I'm now using here. So the next now is for me to define AIGROP, which is the protocol that will enable loopback reachability and MPLS labels to be propagated. So I'll now say uh, router AIGROP. I'll be using name mode. Name mode. The ASN I'm running is 65,000. Okay, let me just use a 65,000. I'll define the address family. I'm using IPv4. Actually, address mode is very robust to use because it has several address family it supports. You can also use address family IPv6, and then you can also it's supposed also support VRF. So I'll use VRF in this case, and in this configuration you will see it. Address family IPv4. Then I'm using IPv4 address unicast, and then the autonomous system is going to be 65,000, and that is all that is needed here. Then the network I will specify so that to show the interface that is going to participate in this process. And interface is the tunnel that are defined 10 dot 172 dot 18 10 dot 10 dot 10 dot 0 10 dot 0 with the white card is 240. So I will spell the white card define it which is 0 dot 0 0 dot 15. So I will talk about white cards in one of the videos later on. So this is that for this. And then what else do I need? It's actually a long topic, but if you can stay through, then let's go ahead. I'll define this, and then what else do I need to define? Um, let me show interface brief. I want to show IP interface brief. I want to advertise. I don't want to do the distribution of the network. I want to advertise the the loopback IP, which is going to be 10.10.10.1, and then the white card is going to be 0.0.0.0 because it's /32 IP. So that's that. We exit, and then let me do show run session EIGROP because I want to use test editor and place them in this router so that everything can come up. So I'll just copy this. I don't think I even have. Okay, I'll use. I need to remove the loopback. The loopback here on this router is two. Is two. Is two. In a moment, I should be seeing the IGRP coming up. So a new adjacency has been formed, and then the LDP label has come up. This MPLS label has come up. So I'll do the same thing here. The interface here is the loopback here is dots is three. Loopback there is three. I'll copy and I'll place here. It's just to buy time anyway. And then adjacency has come. The loopback here is four. And I move that four. copy and I'll paste here. Now I want to show you the beauty of the DMVPN that I configured earlier on. With your GRO, you will see about three ops. So I will not exit this because there's something I still need to do here. Do show IP route. Should be do show IP route via GRP. So these are the routes I'm having. Do show IP route via GRP. So I'm having one here. Let me think. Do show. I should be at do show IP route EIGRP. Having one. So what happened is due to the hub and spoke technology, because in this my diagram, all these other router are transversing towards this hub. The tunnel that I created is here. So all of them are pointing to this for their route. So I need to go to the one section of do show IP protocol. I have to go to the one section of the EIGROP and disable the okay router EIGROP. Yeah, it's like I'm in a process already, but I just want to be sure. Yes, and this. So address family IPv for Unicast autonomous system 65,000. And then with AF dash interface um, tunnel 10, I'll say no split horizon. The reason is because of this topology, everything is going to the router. So this router, the split horizon is actually on that interface tunnel. It's actually not allowing this router IP to go through to this side and from here to go through back to this side. So I have to disable the split horizon at the up. This is the only place I need to do this, and then I will have other routes. So the adjacency has been reformed on all the router. So let me reconfirm the route so that I can have the same routing table everywhere. Do show IP route EIGROP. Do show IP route EIGROP. So you can see I have all the routes. Now let me see if I did do show run interface tunnel 10. Because there's a command I need to do on this tunnel. IP initial P shortcut do show run interface tunnel 10. Okay, I did IP initial P shortcut here. Do show run interface tunnel 10. IP initial P shortcut is done here too. Do show run interface tunnel 10. Do show run interface tunnel 10. So this will be IP initial P redirect. So for this, like I've not done for this, I have to do interface tunnel 10 IP initial P shortcut. That is to enable the DMV pin phase 3 tunnel to be created. So now let me run um, a trace route to this do show IP interface brief. So I will run a trace route to this interface here, and you will see what is going to happen. Do let me exit trace route to 10.10.10.2, trace 10.10.10.2. So I don't have reachability. Okay. So now the information, the trace around from here came to the hub and then moved down to PE1. That is why you are seeing the first one, you are seeing this first dot here. If I run this same trace route again, we will have only one tunnel because the tunnel might have been created by that time. You see, now I have only one tunnel. Why this dot was showing is that NHROP was busy looking for the shortcut to use with the public IP to create a tunnel. So now look at it, the shortcut has now been created. If I go to do show, if I go to show IP route, you see this sign here. It's a sign of the tunnel that was created. Initially, it's not there, but after a while, you will not see this again. So that's one advantage of this DNVPN. You understand? It is not a resource hungry. It is not going to leave this route permanent there. After a while, it will free the route. So if there are so many several voice calls, a tunnel will be created immediately, and after a while, those tunnel will leave. So that's one advantage. The CPU will be freed. It's just to make use of the CPU when it is being used, and it is being freed when it is not being used. That's one advantage of the DMVPN. So this is now ready. So now we'll now move now to defining the BGP as well as um, that's the MP BGP and then the VROF. Those are what is now left, and then I'll confirm reachability to those ends. All right. So earlier on, I let me still show you one more thing about this DMVPN. Let me just do show IP routes. So do show IP interface brief. So I want to run a trace route from PE2 to PE1. We show IP route. So I want to show run IP trace route from PE2 to PE1. And this topology, the design I did is that every both the route reflector and the provider edge routers are pointing to the hub, which is the P. And then at this particular P, if I'm doing a trace route, it has to transverse because it's a tunnel, it has to transfer through the hub and from the hub back to PE1. That is the traditional design. And in phase one, that is the first thing. Phase one DMVPN, that is what it's going to do. But for the phase three DMVPN, a tunnel will be created directly using the underlying network dynamically. So as I've earlier explained, but I don't want to take too much time on that. So let me quickly run the trace. Let's say do trace 10.10.10. Okay, I want to run from 2 to 1. Do trace 10.10.10 to 2. Yes. So it will show me dot dot dot. Those first dot 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 is just the NHROP trying to look for the next stop solution protocol. So it has actually goes through two ops now. And if you check, that percentage sign is not here. So if I run this trace route again, a shortcut has been created. So you see, it's only one hop now. Only one hop, no longer this first hop before here. Only one hop. If I run it again, only one hop. Now, if you come to this IP route, you don't see that percentage NHROP shortcut. If I run that command again, do show IP route, you'll not be seeing that dynamic tunnel that was created. So if you come to this place, a dynamic tunnel has now been created through uh, NBMA, NBMA, through directly to each other without transversing through the up dynamically. But after a while, you will not see it. So that's just the beauty of DMPPL over the traditional GRO tunnel that will maintain that row up continuously. So so right now, like I said, I'm going to be going to BGP. So without any wasting of time, this route reflector router from the topology from this diagram, this is going to be in my route reflector. What am I? I'll explain in one of the upcoming videos about route reflector. It is just one of those tools to solve scalability issue in BGP. BGP confederation is also another option, and then or you do a full mesh. A full mesh is that I will do an IBGP to this, I'll do an IBGP to this, I'll do IBGP to this, I'll do to this, I'll do to each one of almost each one of those router, and that is going to make the network messy. So, but with track reflector, because actually BGP is a ear-to-ear kind of design protocol because it's a path vector protocol. So, but with track reflector, at least a route from here can be reflected to this, a route from here. So you're just that way, or this route from here can be reflected to this. So I will explain one of those route reflector technologies or rules. So for the now, let me go straight to our router and configure this. Earlier on, I did do show run interface tunnel 10. I did configure MPLS IP here. This MPLS IP is actually optional for a route reflector router. You understand? I do not have any customer CE, customer edge or customer premises equipment connecting to it. It's just to reflect route. So it's the route reflector. So now, and this other one are the route reflector clients. So now I'll make this route the route reflector, but I'll leave the MPLS IP anyway. So I'll say router BGP 65,000. That is just to be a route reflector. That's what I'm using it for. So I think I have done this before. No BGP default IP before Unicast. Okay, I think I've done that before. So and now neighbor, I'll make use of peer group neighbor arrow peer group. Any other option? None. Neighbor arrow peer group. Because this peer group is good in production environment in the sense that if you have so many internal BGP, IBGP you want to form, which is a multi-protocol BGP, you don't need to be configuring each one of them, deactivating each one of them. So it's a pair group, all of them can be activated. So or whatever it is we want to do that pair group can be done with it. So I'm not saying neighbor arrow remote AS is going to be what they call it 65,000 since it's an internal or interior BGP. Then 65,000. I'll not say neighbor. Let me check the. I was trying to look for do show IP interface brief, excluding unassigned. So this loopback one. I'll say neighbor arrow update source should be the loopback one. So that's that for that. So I'll now say I'll now go to the corresponding address family name because I did no BGP default IP before because it will be activated if I just do this enable arrow and I form adjacency. But I have to go to the corresponding address family to activate them. It is just to make the work nicer. VPN V4, address family V4, unicast, unicast exactly. So I hope one of these days ISP will make use of multicast. And now say what address, and now say neighbor um 10.10.10.1. Oh, I've not associated this this neighbor arrow arrow. Is that so? Neighbor 10.10.10.1 pair group arrow. I'll do the same thing for loop back 2, which is here. I'll do the same thing for loop back 3, which is here. I'll now go to the address family. I didn't define it earlier on, so I'll now say neighbor 10.10.10.1. I will activate it. Neighbor, I'll activate dot 2 as well. I'll activate dot 3 as well. Neighbor arrow, I'm going to do send community extended. This is for VPN route. Um, I think that is that for that. Um, do do I need to even do that? Let me just okay. Do show run session BGP. So let me form adjacency now right from here. Router BGP. Okay, there's something else I need to do. I have to define route reflector as well. Um, neighbor arrow, that is the use of route reflect pair group. If I didn't do this pair group, I would have specified each one of them as route reflector. But with the pair group, I just issue this command and it will take effect on all of them that are peer to that pair group. Route reflector client. So I'll come to this BGP 65,000 neighbor 10.10.10.4. It's an internal BGP 65,000 neighbor 10.10.10.4. Update source is loopback 1. Address family VPN B4 unicast neighbor 10.10.10.4. Activate any mention from now it should be off. Neighbor 10.10.10.4. Send community extended. That is what I need to be done here. Router BGP 65,000 neighbor 10.10.10.4. Remove TS 5,000 neighbor 10.10.10.4. Update source go back 1. Address family VPN B4 unicast neighbor 10.10.10.4. Activate and I'll send community extended. This should be up any moment from now as well. Did I send extended? Yes. I do the same here. That's a BGP 65,000 neighbor 10.10.10.4. Um, remote AS 65,000 neighbor 10.10.10.4. Update source back 1. Address family VPN V4 unicast neighbor 10.10.10.4. Activate neighbor 10.10.10.4. Send community extended. Anyway, from now this should be activated as well, so it has been activated. So MPBGP is ready. So I will now go to define the VRF. I'm going to define the VRF. So basically nothing more to be done here. And if I want to confirm this route, do show BGP DPNV4 DPNV4. Okay. Unicast. Unicast. This will show me the unicast. Unicast. So these are the adjacency that was formed for the VPN V4. And if I'm to check the BGP what do you call it, BGP table of stop here. So actually there's nothing coming up there. So you want to check the BGP, all the BGP address family, um, summary. These are the association with the neighbors. This is the IP for IPv4, and this is for VPN-v4. And if you want to do for to check the BGP, should be having topology here. Okay, want to check the BGP table. I'll stop at this level. So uh, from the upstream service provider is advertising a default route to me. This greater sign means it is installed, and this is in the BGP table here. So the PIV4, no route is coming from there yet. So that's that for the route reflector. So VROF definition. I'm at the provider router. So for the sake of this, well, for the sake of time, I don't maybe let us go ahead and see. So for the provider router, I'm going to define for blue, which is this blue company, which is A up, which is A up. I'll say A dash up, and then the route target is going to be autonomous system number, and then the client identification or identifier number. I'm going to use a number identifier. I'm going to use the loopback IP here to distinguish this particular router. And for that client, is going to be one. And the route target export. I will export this target to the cloud, to the Mpls cloud. So let me do for this VRF definition for this customer at this blue is ARO1, uh, ARO1, and then route target 65,000 ASN number. The identifier, the loopback here is 2. The identifier for that customer is going to be 1. And then route target export. I'm going to be exporting this guy out. Um, and then I'll do the same thing here. PRF definition for PE2, whether edge router 2. The blue guy here is a, okay, let me see. The blue guy here is a, supposed to be, in this take, supposed to be a arrow, a arrow 2, because they are the ones that donated as a arrow 2. Okay, this a arrow 2, a arrow, a arrow 2. And then route distribution is going to be 65,000 naira. 65,000, my bad. Then, and then the loop back here is going to be, once the loop back in this place is 3, multiplier for that point is 1. So I just did this to make it easy for me. So route target, I'm going to be exporting this out. I've exported those out. Route target export. So route targets for the provider edge, I'm going to import these two. Route targets import. I will import these two guys. Then here, route targets import just for full reachability. I will import these two guys. So that I can share full table. Actually, I can just what I'm supposed to do actually is just to import only this one will import these two guys. This will import this will import this. That is enough. So the interface can do whatever I want to do. But I want full all the routers to be reachable to each other. So I've imported this and I imported this. So this guy now router gets import. I'll import this other guy here and I'll also import this other guy here too. So that's that for the VROF. So I will now go to the various interface connecting to these customers. I'll go to this and then define the VROF there. So I'll go to interface for this. Okay, for this guy here is on a P router is interface E1/1. Excuse me, interface E1/1. No, no short. There's something I'm supposed to have done here. I'm supposed to have address family IPv4. Very important. Otherwise, it will not go. Address family IPv4. Address family IPv4. So I'll go to the interface and assign them to it with the command forwarding. VRF forwarding. So I have a up. That's the A up there. A up. I'll now assign IP address. Like I said, I'll be using the same IP address for those two routers. 172 dot uh, uh, 172 dot remember my tunnel IP is 18. Ideally I shouldn't be able to use this, but for the sake of VRF I can. 10.10.1 255.255.255 and it is possible because of Mpls because they use labels dot 240. So that has been done. Then I'll come to the interface for this guy here, interface E1/1, E1/1. I will say um, BRF forwarding, the question mark, and that's the BRF present in this router, and that's that. And now assign IP address. The IP address I sent earlier on was 172 dot um, 18 dot I used dot 10 earlier on, so let me use dot 20 dot 1 255 dot 255 dot 255 dot 24 dot 240. I will no short it. No, no short. I'll come to this guy for this blue customer. It's in E1/1. Go to interface E1/1. No, no short. VRF forwarding question mark to see what I okay. This what is there. IP address 172.18.30.10. Okay, dot 1. 255.255.255.240. So that's just it. So basically, this router I have done configuring MPBGP for customers on the blue routers, on the blue side of the topology. These guys, this guy, this guy. I want to confirm. I want to confirm. Let me go. Let me, so um, earlier on I said I'm done with the configuration, but there's some little things that was missed out that I want to do. 65,000 router BGP BGP 65,000. So I have to define the VRF instance, address family, IPv4, this time IPv4 unicast. So there's an option for VRF because I'm using VRF for those customers. VRF, and I'll specify the VRF name. I specify for this B router is A dash hub, A dash hub. One has to be careful. A dash hub. So that's that for this. So at this point, I need to do what we call connected, redistribute connected route. Connected being in reference to the VRF. Um, so I can actually use just metric one if I want to, and I'll start the redistribute connected. That's an optional. And if you have some routes you want to exempt, you can do, but I'll do that. I actually don't have a static route in that config. Assuming I have, I will do that. So I'll do the same thing for this router. Let me do show VRF, then router BGP 65,000. I'll do address family IPv4 unicast VRF is going to be a dash arrow one. Let me verify this to show VRF so that I'm sure I'm referencing the right thing. A dash home. Okay, good. So I'm going to do the distribute the connected metric one. Metric one is optional. And do the same thing here. Router BGP 65,000. Address family IPv4 unicast. And I will verify the VRF. Um, let me okay. Um, unicast. The VRF is VRF is VRF. Let's say redistribute connected with option of metric one. So I think that's dot for that particular interface, for that particular config. And let me exit. Let me exit. Let me, let me check. You show IP route VRF. It's A dash of. Okay, good. I'm having some BGP routes coming to me here. I'm having some BGP routes. Let me show IP routes BGP. Show IP routes VRF A dash arrow 2. We have another BGP platform forming up here. Do show IP routes BGP. Do show IP routes VRF. Do show IP routes VRF. Do show IP routes VRF A dash arrow 1. So I'm having two BGP routes here. I don't think I'm assigned. I've forwarded an interface here. Let me do show IP interface brief. Okay, the 20.1. Come on, now having connected interface here. We should run interface in. Oh, I've now associated the BRF to it, so that's why there's no connected route showing there. So interface E1/1, BRF forwarding, what's the BRF here? AR1. So I will have to assign that IP again, IP address 172.18.20 dot 1 2.5.2.5.2.5.240. So let me rerun it and see. So now I have a connected interface of two BGP routes coming from here. I initially saw only one route, so I was wondering. So then I should have two routes now. Good. I'm having two BGP routes, and the distance is 200. So to verify if I can ping this do show IP interface brief, excluding unassigned. To verify if I can ping this VRF interface from the provider router, I'll do do ping 172 dot 18 dot 30. Do ping VRF and the VRF I specified in this router is a hub a hub. What other option? The IP address 172 dot 18 dot 30 dot 1. I can actually source it from that Ethernet Ethernet 1/1. So the ping is successful. So actually with this, I can actually just give the customer those show IP interface brief. I can actually just give this any of this range to the customer. The same if I do show IP interface brief. The same thing with this 172.17.20 do show IP interface brief. The same thing with this to the customer their work. By doing that, that is static routing. But in my case, I said I'll be doing BGP with this router, and here I'll be doing what do we call it, OSPF, and here I'll be doing EIGRP with this customer. So no static routing basically in this router to these customers. So let me enter this hub now. Let me enter this hub. I will do a BGP, and the BGP I'm giving a 650 now. There's no IP, no configuration in this customer router. Say config T, and then the interface is 1/0. Interface 1/0. Interface E 1/0. IP address from that range 172.18.10.2 255.255.255.240. I will no short it. Remember, this is the same IP I use for tunnel. It is made possible for me to assign the same IP. Okay, this is the let me see. provider. Okay, I used 10 here. Sorry to say, it was this IP I used here. I use this same subnet that is in my that the service provider option gave to me for this customer. This was made possible because of the VRF that is running on this ETA 1/1. This look at the 1610.1, 1610.2. It is slash 30 IP, the same subnet. But because VRF is running here, that is why it is possible. It is assumed it is running, not assumed, it is running on the VRF table. So the IP address is actually this one is going to be .2. Let me see. Do show run interface E1/1. It's a slash one 240 and the VRF forwarding is there. So let me change the IP address. This is actually 16. It's actually 16. What is it there? 16 yes. 16.2. Let me confirm reachability ping 172.16.10.10.1. Okay, it is successful. So router BGP. Let me do go back interface go back one and the IP address I'm giving for this go back. Let me see. Um, 10.20.20.1. So 10.20.20.1 255.255.255.255. Then router BGP number is 65001 65001. And then what else? Um, I'm going to do neighbor neighbor. The IP address I assigned earlier was this guy. It is true. And the remote AS is 65. So this one that I'm doing is actually a premium service, and you're going to bill the customer seriously for running a protocol with you. In fact, helping you to run your network for the customer. That is just what we are doing here. So neighbor, that's how we distribute all the connected routes at the client end. Please, in BGP, do not redistribute connected or static routes except on a rare condition, just as I'm doing here in VPN before route for customer IPs. So I'll come to I'll go back to router BGP 65,000, the instance that defined earlier on address family IPv4 unicast VRF a dash hub. I'll do a label adjacency here. Neighbor is what is the IP? Yes, I think that is the IP.2. Neighbor remote AS is remote AS is what is the remote AS I gave this guy now? 6501 6501. And I'll say okay, I think I've done redistribution connected route here before. I'll say AS. I say neighbor this guy, neighbor this guy, 172 dots. It was a wrong IP address I am using here. Is that the right IP? I did a pin things to this guy. Oh, I'm still using the wrong IP here instead of this IP address. 16 actually. They show IP interface brief. Yes, it was 16. And then this guy here should be 16 too. It will be opening there for now. See, no. So, so it is up actually. Neighbor, this guy, which is dot two. I'll say else override. That is just what needs to be done here. Remember, I've done a distribution of connected route as well. So if I should come to any end it, if I should come to show IP routes, remember this does not is not always running on the DRF. So I'm getting the route from these two other routers at the hub router. Let me just write. I guess I'm done with this. So um, I'm done with the hub router. I'm done with the hub router. So I will go to this PE router, PE1, PE1 router. Sorry, the video is taking long, but it is actually an interesting lecture for advanced uh, routing engineers. So for the PE routers, for the PE router, I have to form an adjacency for this. And I earlier said I'll be doing OSPF for this, the Azure for this. I've done BGP connections to this. You can do static route, just give them IP and they do what they want to do. I'm doing OSPF and the Azure for this. So I'll come to this command. I'll come to this command for the PE router B BGP 65,000. Let me check the do show VROF. Say address family. That's the reason ascent of address family, IPv4, address family IPv4 unicast. The VROF I'm referencing is this guy here. I think I've done redistribution of connected routes here before. Redistribution of what connected routes. I'll now say um, I'm not done OSPF there. So let me quickly um, let me redistribute OSPF if I can. If it will allow me, because I'm supposed to have defined it. Redistribute OSPF one with the option of metric. I have to match because OSPF is actually because of the way OSPF work. I'll match internal and then external because of it has internal and external route. So I'm matching it and redistributing it with the option of metric one. It's not important, but let me just add it metric one. So I'll go now and form with OSPF process router. Let me exit this router OSPF one. I'll take on VROF. The VROF is ARO1. That's that. So I'll form um, the IP that I assigned on that interface to show IP interface brief excluding unassigned. On that interface is this IP or say network or the adjacency to form 72.18.20.0. Um, I don't even know. Let me just. I don't know if this is a subnet map we show from interface E1/1 240. So network um, 172.18.20.0 the white card dot um, dot 15 at area 0, at area 0. So I'll stop there. So I'll redistribute the what do we call it, the BGP. Redistribute BGP 65,000. The metric is something this when you are doing the distribution of protocol from source protocol to destination protocol, you have to state the what do we call it, the seed metric to which to use to calculate it that particular route in the next, which is the new domain or the new route or the new SPF table to use to calculate. So I'm going to use redistribute metric type metric type. Cisco by default use SPF type 2. So let me just go by the type 2. What else again? Um, do I even need? Let me just use the metric. It's optional. Type 2 is important, but type 1, those are also good. But let me just use it as let me use 10. So that is that. And then I will exit this um, OSPF 1, the process. So SPF 1. So let me quickly go to this customer router at this end. So I should now be able to reach this guy here. Maybe I form OSPF adjacency. So I'll do config T, interface facing this theta 1, interface E1 slash 0. I will not short it, IP address. I will not short it, IP address. What is the IP address assigned on PV1? Um, the IP address I assigned is this guy here, and I'll assign that there, G.2, 255.255.255.240. I'll try to ping dot one. If it is successful, do ping. If it is successful. So um, router OSPF. Process number does not matter. The network is 0. Wildcard dot 15. Area wildcard is dot 15. Area is 0. I want to do the distribution of decency has come up of connected route. You show IP interface brief, interface back 1, IP address, interface loop back 1. The IP address I'm using here is 10.20.20.2. Remember, I use 10.20.1. That's what I want to use to confirm um, IP 10.20.20.255.255.255.255. Is it end? Let me show IP route, show IP, show IP route. So external type 2. I'm actually having 10.20.1. If I go to hub, the hub show of the customer show IP route. I'm having 10.10 BGP dot 2 because to the external it is doing eBGP dot 2. So if I want to confirm the IP address within the service provider, show BGP what they are forming, show BGP uh, VP VPN V4 VPN V4 unicast. And if you want to go by the route description, but let me just use um, all because it is the only. So this actually can show me the routing table. So this is what I am getting from um, the VPN v4 route. So, but let me define it by VROF a dash hub. So from the hub, these are the routes that are being populated from the various router interfaces. Earlier on, when I do this command, I don't see it. So they are installed in this router. Are you getting it? So that is how to do the configuration. So let me go. I've done for this is BGP. This is BGP communication with the customer BGP OSPF. I'll now go for um, EIGRP. I think this should be the last. And I will advise that you can replicate the same configuration you see me do for this B here on this red so that I'll reduce the length of this video. Then I'll come to this arrow 2 now. First and foremost, I have to work in the PE2 router. So I'll go to PE2, I'll go to router BGP 65,000. I'll go to address family IPv4 unicast, the VROF, I don't even know the VROF. Let me verify. Do show VROF. So address family IPv4 unicast VROF is this guy here. I'll do redistribution. I think I've done that before. I'll do neighbor. I'll do redistribution of EIGROP 65,000. With the option of metric, I can just put metric one if I want to. Option metric one. So that's that for that. And then I'll now redistribute the PGP into EIGROP exits. I'll say this is the good thing of using EIGRP name. It's actually an advanced router. I'll go to EIGRP and say router EIGRP. Let me see. Do show IP protocols. Okay. Router EIGRP. That is the name mode. I'll now say um, address family IPv4 universe autonomous system. Now, autonomous system is um, component IPv4, IPv4 BROF. I'm going to specify. I'm not working within the general address family. I will specify the BRF and the BRF are configured earlier, which is A dash arrow 2. A dash arrow 2. Where's that BRF? Which is this one here. A dash arrow 2. That's the advantage of using name mode. And now specify the autonomous system. So the autonomous system for this router is 6501. Is 6501. So I'll specify 6500 5001. I'll press enter to show IP interface brief, excluding unassigned, excluding unassigned. So for the VRF link, this is the IP address. I'll specify the network to bring up the EIGRP, and then write card 0.0.0. Let me check the IP address again to be sure. I think pretty sure, yeah, pretty sure wrong interface. This guy. /240. Okay, that's what I want to confirm network 172.18.30 dot 0 dot 0 dot 15. That's the white card. I'll go to topology mode, and then I'll redistribute. Um, See, this is where, what do we call it? Um, prefix list is also very important, but I'll do that. I'll do that. So I'll redistribute BGP because it will cause, it might cause recursive routing. Redistribute BGP 65,000 with the metric of the bandwidth 100,000, 100,000 fast internet, 100,000 fast internet, the Ajero P1, 255 for effective reliability, and number one, 30 bandwidth MTU 1500. Then the route map, C map. I'll have to quickly specify this map. How is it? Let me do show IP interface brief excluding unassigned, and then the IP here is a slash cat IP. Let me export the route map. Do show run session route map. So I can use text editor. I'll do the same thing for the prefix lists. So for the P router, let me do that. Match IP address prefix list is not that. And then the prefix list. The prefix list for this P router, the IP address is 10. The network here, okay, is 8. That's it. Then paste. IP prefix list, prefix 1. So just connect this. So I think that's that for that. Then sure. Let me quickly go and make ERGRP session for this router on P2 to show that's there already to show one session ERGRP, and the interface for this is E1 slash 0 on P2 interface E1 slash 0, uh, no, no short IP address on P2. The IP address I have here is this guy here. So 255.255.255.240. I guess that was that router. Yes, that should be what's there. 240. That should be, yes, 240. 240. I think that's that for this. And then what else do I need here? Let me confirm. Do the pin this guy. Okay, and that's successful. I'll use the classic mode router ERGRP. The autonomous system I use for PE2 for that VROF is what 6501. Good. So 6501. And the network is going to be the network address of this guy here. The wildcard is 0.0.0.0.15. I want to redistribute connected routes. So adjacency of the form exit show IP routes. So I'm actually having routes now coming from those places. Let me just save these guys. Do copy, run, start. I always like using do. So basically, these routers now are connected via BGP, Mpls. There are three connections. So if I want to reach the loopback, let me show IP interface brief. That's a loopback here. Show IP interface brief. That's a loopback here. I don't think I've done loopback for this guy here. Show interface brief. IP T interface loopback. One IP address. Then 20.20.3.255.255.255.255. And so let me do trace advantage of DMVPN from the up. Okay, let me just do from here to this guy here. Trace 10.20.20.2. That's interesting. Why only one up? Okay, dots from here to dot three. Yes, there's something happening here. Show IP route. I'm having it. Show IP route. Show IP routes. PRGRP. Show IP routes. OSPF. I have dot one. I have dot three. Show IP routes. PGP. So anything trace 10.20.20.2. So I have one shortcut there. Let me see if it's going to reduce. So I now have three ops as against four ops before, and the MPLS label showing. Anyway, those are just the steps for configuring um, VPN V4 routes, also known as uh, MPLS layer 3 VPN. So I'll be dropping some of the configuration steps that I took um, under this video session. You see the link, follow it and check, and then implement it in your own lab as well and learn how it is being done. So for this MPLS layer 3 VPN, still on the Cisco router. So earlier on, the configuration I did stopped at the blue customers, the same customer. So I'll be doing carrying out the continuation for these other ones and that are in pink or in pink color or red. These other ones, which are the B customer. These are the A customer. A hub, ARO1, ARO2, B hub, B branch 1, B branch 2. So I will carry on this configuration. Why the other one was longer was because I have to set up everything from scratch, setting up the ISP, setting up the BGP, NDBGP, and every other configuration. So it was much longer. But at least this will be a little bit brief because right now I'll be making use of it's just I'll be working with the BGP I've already set up, and then just the VRF and the IP. So meanwhile, while I was doing the configuration of the earliest one, let me close this other B branch, this about other B branch. I actually made a mistake. I did a reduction of, let me go check this R2, this R2. Let me come to, uh, let me just open them and check up, and this other guy here too. I actually made a mistake earlier on when I come to a branch router C-config. Okay, let me just show run session BGP. Shows run session BGP. Okay, there's no BGP running because I'm talking about a branch router actually. So PE2, which is the provider edge for this PE2 pointing to this router. That's what I wanted to check before not that guy. Do show run session BGP. So if you come down to this area, I don't know if you are seeing my green mouse. I'm using a green mouse. If you come down to this area here, you will see um, you will see I did redistribution of EIGRP 6501. Earlier on, I did the distribution of 665,000. So that was where the error came from. Instead of 6501, I did 6501 because this router here, ARO2, should show run session EIGRP. I did EIGRP with this router, and they are in autonomous system 6501 and autonomous system 6501. So, so I actually did distribution of instead of 650, I did 65 instead of 6501, I did 6502. That was the error. And if I say do show run session EIGRP, remember remember I did a VROF autonomous system here. Others familiar IP4, unicast, VROF, ARO2 at this point 6501. So that is where that's the one I'm supposed to redistribute, not the main, the ISP autonomous system. So it was the VRF that did with this airdrop with this customer route. So it's supposed to be redistributed in this BGP VRF section. Yeah, BGP VRF section. So basically, if I go now, because the last time the routes were not complete, show IP route. So for the customer end, let me just reduce the route, UIP route, AIGRP. So I'm now having got the complete loopback IP 10.20.1 from the hub, and then 10.20.2 from RO1. So the same thing, if I come to this place, I did OSPF, show IP routes OSPF 10.20.1, 10.20.3.1 be the hub, then dot 3 be the RO2. If I do trace now to 10.20.20.3, I should have a successful trace route. So I should have a successful trace route. So that's that. Meanwhile, the one I want to work on now is going to be um, on these B routers. Let me launch them so that I'll go straight to the information. So for the provider hedge, I'll come to config T. Everything is already prepared. I'll do a VRF definition. This time around, I'll say B, but arrow B, B hub, pointing to the hub. Um, the route target is going to be 65,000, and then the loopback IP here is 1. Definition for the first one I did was 1, so I'm going to use 2 for the second customer this at this hub, and then I'll say route target export is going to be this guy here. So let me come to the provider 2, say config T. I'll do PRF defi- definition. I want to name B dash arrow 1, and then that target is 65,000. The loopback here is 2. The number for this particular client is 2. That target exports this uh, ID for this customer out. I'll do for PE2, config T. Sorry, my bad. Um, VRF definition 65,000 per 3, and this particular customer is 2. So router gets export, I want to export this guy out. So or is that VRF? My bad, wrong wrong definition. That was not my intention. So it will be deleted anyway later after a while. Um, VRF definition um, B dash arrow 2, and I'll say ROD 65,000. The look back here is 3. For this customer is 2. The first one I did was 1, 3, 1. I'll now say um, route target, export this guy out. So let me go to this hub and import. I say route target, import. I'm importing this guy. I'm also importing this guy. That is ASN number and the identifier identity number for the customer. I'm done with this. So I'll say route target import. I'll do for this as well. Say route target import as well for this. And I'll do for this as well. Route target import. Import this or repeat the same for this. So basically that's that for the VRF address family IPv, for to associate them to the address family type. So the interfaces those guys are connected to, they are connected to 10 at the hub. Interface E 1/0. VRF forwarding is going to be B dash hub, and the IP address. I can give the same IP address if I want to, but let me just make it 1910.125.255.255.252. I did the first example just to show that you can assign the same IP address. So, but let me just go unique this time. So I'll go to for this other guy here 1.2. This is 1.0. Okay. VRF forward B dash arrow 1. IP address dot 19 dot 20 dot 1 255.255.255.252. So what's that? So interface E 1/0 no short. Okay, E1/2. E1/2 as well. So E1/2. Let me check. I want to be very sure. The E1/2. No short. VRF forwarding B dash arrow B dash arrow R2 IP address 172.19 dot 30.1 255.255.255.252. So that's that for this. So um what I'll have to now continue with the configuration. So already I've assigned IP, I've assigned IP to the interface connecting to these red guys. And just to show you, I'm just trying to make the video short. These are the IP I assigned. I assigned 172.19.10.1 and yeah 172.19.10.20.1, yeah slash 30 IP 172.19.30.1. While for the B routers are the red ones or the pink ones or so. You understand? So what is actually running here, I've actually assigned the same IP there and they are reachable. B connecting to the provider, BRO1 connecting to the PE2, and is the IP address and is the corresponding IP address. Then BRO2 as well connecting to PE2, which is 1930.1. So let me check I've already configured the protocol as well. Do show IP protocols. Do show IP protocols. So basically for this router here, configure BGP because I said BGP is what I will be using for the hub. So and for this branch BRO1, let me check do show IP protocol. What I'm using here is let me see, do show run session. I think I configured RIP for this session. I've not actually uh, okay, I've not configured anything there. Let me check here. Do show IP protocol. So I did the ERGRP for this. So let me see what so I've not actually used RIP before, but let me see. Router RIP. I need to do this. Um let me use OSPF. Or let me use BGP as well. Router BGP. The BGP is 6502 for this company. 6502. So let me also quickly configure it. I'll say neighbor, since neighbor is the IP address is 192.168, my bad, 172.19.20.2, and the remote health is 65,000. Okay, remote is 65,000. I'm going to redistribute the connected out. This is optional, metric one. So that's that for that. Then let me now come to these provider routers. Let me verify the VROF. Do show show VROF. So I did for hub, I did for B A hub branches and B hub branches. So let me now go to router and configure router BGP 65,000 and then address family IPv4 unicast BRF is B hub and the remote neighbor is 172.19.10.2, which is this IP address, and the remote AS is 65002. So I'm going to do AS neighbor 172.19. It is up actually 19.10.2 AS override. I'm going to redistribute the connected route with metric option. It is option by metric 1. I would have used 10, but let me just leave that metric 1. I think that is all I need to do here. And then for this PE1, I'm not going to PE1, which is connected to this BRO1. I did BGP2 for that. So let me go router. Let me confirm that DROF. You show DROF. And now say router BGP 65,000. Router BGP 65,000. Address family IPv. 4 unicast BROF is going to be BRO1. Neighbor 172.19.20.2. Remote AS is 65002. AS neighbor 172.19.20.2. AS override. Why is this not coming up? Okay, it's up now. And then we want to redistribute the connected route. BGP to BGP, I do not have to go into it. So everything has been done right here. So this is for this. If I should check now for between this hub and this hub, I should be having do show IP route at the branch end. So I'm having some route coming from the hub. Do show IP route because I've not configured loopback. I'm having some route. So let me just configure loopback interface loopback. In this, I'm going to use 10.30 range. I can use the same as this, but just for a later job, since BGP is involved here, I'm going to use different loopback, which is this 10.30.30 range. So for this hub, interface loopback 1, IP address 10.30.30.1.255.255.255.255. Because I did distribution of connected route, I should be seeing that route in this router too. I say interface loopback 1, IP address 10.30.30.2.255.255.255.255. Because I did distribution of route, I should be seeing that range. If I go to check the IP route, let me say to show IP route. So I'm now having two routes here. The 10.30.30.2, the loopback I configured for this guy. I say do show IP route BGP just to streamline it. So I'm now having I'm supposed to be seeing that. Okay, I'm having let me see if I configure this. Then I'm going to distribute this BGP. Do show run session BGP. Okay, I did not redistribute the connected route yet. So redistribute connected. That is it. So let me confirm again. I should be having two routes here. Okay, so now I have the route 10.30.30.1. So that's that for that. Now, this particular one, I'm going to take my time because it involves two different routing protocol. And this PE2 is one pointing to this customer edge router PBRO2 for this diagram, PE2 to this guy here. So I'll now come to this PE2. I'll say, let me show run session EIGROP because I see IGRP running on this router before, and I've used it for another VRF. I want to use it for another VRF as well. Why this one is coming up? Let me see if I've configured EIGRP. Okay, I've configured EIGRP already. Um, we should run session EIGRP to confirm if I redistribute documented. Let me come back here. So it has shown giving me the option. So I did come to this address family PROF, and this is the former address family I used. So let me now use another address family with VRF. Address family IPv4. That's the good thing about named EIGRP, VRF, autonomous VRF IPv4. Okay, unicast VRF, and then the VRF I have here. I didn't even confirm earlier. I was supposed to confirm before. Let me just confirm. We show VRF. So BRO2 address family IPv4 unicast VRF is going to be B-RO2, and the autonomous system number is 6500 is 65002. Let me confirm that. The 65002. And that's what I think I believe I configured here to 65002. So and that's all. So the network IP is 172.19.10.0.0.0.3. Go to topology base. I'm going to redistribute. I'm going to redistribute. I'm going to redistribute the B the BGP. The BGP is 6500 with the option of route map that I configured earlier on. C map. Yes, I think yes, that's it. Let me confirm that route map to show route map. Let me confirm that route map. Yes, sigma, because if nothing is defined, it will have an implicit deny. All routes will not go through. So it is defined, prefix places are added, so every other thing is okay there. So um let me I've done that here. Let me go to PGP as well. Um router BGP 65,000 address family happy before unicast ERF B dash B arrow B dash arrow 2 to show ERF B dash arrow 2 redistribute EIGROP 65002 redistribute EIGROP 6502. I hope I've defined the default metric on the router in the IGRP configuration mode, and with option of metric 1. So let me quickly go to that the IGRP again and confirm. If that was done, um, topology is, let me just confirm even before coming in, do show run. I should have done default. Let me just do default metric, default metric is the bandwidth gigabit fast Ethernet 1 255 1500. So on the hand is alright. I should now, I don't have a GCC yet, and why that is to show EIGRP, to show EIGRP IPv4. No need, no adjacency. And let me do the same thing here. Session EIGRP. To show IP interface brief. Let's create one on a side. Okay, let this come with this result. Autonomous system number, is it the same? Or not the same? Okay, the same 65002. But I use a different name. 65002 should come up. 65002. And then the network. I didn't specify the network. I did 10. Oh, wrong network address. Correct. Let me 65002. What did I do here? I did not specify the right network here. Okay, let me just correct that now. Okay, so I now have adjacency. So let me confirm if these routes have been populated in this route. I do show IP route, BGP is what I did here. Do show IP route BGP. I don't think I've done loop back for this. Do show IP interface brief, interface loopback one, IP address 10.30.30.3 255.255.255.255. Let me confirm again. Alright, so I'm getting the routes now 10.30.30.3 and the same here. Let me check 10.30.30.3. So let me do a trace route from here. Do a trace 10.30.30.3. the trace is successful, and this is how you know what the ISP provided for you is MPLS, because you'll be seeing the labels. Let me rerun that trace again. So that's that for this particular router. I think everything is successful. If for some reason, as a service provider, you want to confirm the route you are getting for each VROF, you can actually use the following command: show show BGP show BGP. Let me confirm this VROF. Show VROF. So for the route I'm getting for the hub, I can just say show BGP because it's VPN v4 route, VPN v4, VRO, VRO, VPN v4 unicast, VROF for A. I want to confirm the route, we confirm the route I'm getting. So these are the routes I'm actually getting and they are installed. And this is the next up, and this is using the loopback for reachability for desktop, and the next up interface and every other information you want. And if I want to confirm again, I go show IP route VROF in reference to that VROF, and I see the routes I'm getting. Let me streamline it. BGP. So these are the BGP routes from that VROF that I'm having, and if you compare them with the BGP table, you will see those ones that are installed are also there. Are also there. So and so you can also confirm for VROF for B up show IP route VROF for B up, and you have that. If you want to check the BGP table, show BGP VPN v4 VROF BGP v4 unicast VROF and VROF and then the VROF name, and you see the BGP table. And maybe to show the neighbor adjacency for IPv, show BGP, BGP IPv for unicast summary. So this is what I'm having. Then BGP VPN v4. Let me see VPN v4 unicast. Okay, all summary. So those are the neighborship that we also formed. This was with the loopback, and this was with the customers that are connected using VPN v4 technology. So basically, this comes to the end of today's session on BGP. Please, if you like my video, kindly share, and then you can ask your necessary questions, your questions, and also let my other people know about my content. I still have more interesting content that will be coming up. For this, I have carried out configuration using what do we call it, Cisco routers, and this VROF session, this MPLS layer 3 session using the VRF as well, actually separated these customers, and if they were in just one routing table, for example, they would have been able to reach each other if they are not using tunnel. If at all, they should be able to reach each other, but with the VRF, they are actually totally isolated from each other. Someone said VLANs, VRF are to layer 3 device as to VLANs to layer 2 um, devices. So and that comes to the end of today's session. I do hope you enjoy my video, and do take care and stay blessed. Thank you.